Welcome to the part 4 of the UML syntax presentation. In this presentation, you will learn how to create and interpret the activity diagrams. The course symbol used in an activity diagram is the activity state, also referred to as just activity. An activity is a state of doing something. It may be a real-world process such as buying tickets or the execution of a software routine such as a method on a class. In this slide, buy tickets is the activity. You can also see the start symbol before the buy tickets activity. A fork has one incoming transition and several outgoing transitions. When the incoming transition is triggered, all of the outgoing transitions are taken in parallel. In this diagram, you can see one incoming transition and two outgoing transitions. A guard is a condition that evaluates to true or false. In the slide, opera time is the guard condition. A branch has a single incoming transition and several guarded outgoing transitions. Only one of the outgoing transitions can be taken, so the guards should be mutually exclusive. Using else as a guard indicates that the else transition should be used if all the other guards on the branch are false. In this slide, if it's time for the opera show, then enjoy opera activity is executed. Otherwise, buy popcorn is executed. A merge has multiple input transitions and a single output. A merge marks the end of conditional behavior started by a branch. In this slide, you can see that the enjoy opera and buy popcorn activities goes to the merge shown at the diamond at the bottom. The activity diagram describes the sequencing of activities with support for both conditional and parallel behavior. Branches and merges specify conditional behavior, whereas forks and joins indicate parallel behavior. If the activities occur in parallel, it means that the sequence between them is irrelevant. A join completes all the parallel activities. With a join, the outgoing transition occurs only when all the states on the incoming transitions have completed their activities. Forks and joins must match. This means that every time you have a fork, you must have a join that joins together the thread started by that fork. In the slide, the wait in line and use cell phone activities join at the bottom as shown. You can add a condition to a thread coming out of a fork. The result is the conditional thread. In this diagram, if the ringing condition is false, then that thread is considered to be complete as far as the join is concerned. In the slide, the end state is shown after the drive home activity. A thread that comes out of a fork can itself fork with the new threads coming back together before reaching the matching join. If a thread coming out of a fork goes straight into another fork, you can remove the second